Hey guys, welcome to a re-recording of yesterday's Git and GitHub lecture. I'm sorry I'm having to re-record for a second time, but my computer is really high on storage, so hopefully I can get that fixed and we won't have to provide a different experience for those of you who aren't able to attend. So again, today's lecture is going to be on Git and GitHub. This is going to be a very important lecture for those of you who are going to be collaborating on code in future projects, as well as for the hack challenge. So I highly recommend you stick through this and even follow along if you can. So let's start with a little bit of a conceptual overview of what Git and GitHub is. So what are they? Well, GitHub is an internet provider for hosting software development projects. So for those of you who have used Google Drive, you know that Google Drive is an internet provider for Google Docs, Google Sheets, all these documents that you would have to frequently interact with. You can think of it as Google Drive, but for code. So if you look at AppDev's GitHub, you can see that all our projects are hosted on GitHub, and they're each saved in this own thing called a repository. Now, GitHub uses this thing called Git. And what exactly Git is that it's a distributed version control system. Now, don't let this word scare you. I'm going to explain a bit about what it is. So yeah, let's move on to that. So what is a version control system? A version control system is a system that records changes made in code over time. These changes are stored in this special database called a repository. A repository stores code, it stores your history of changes, it stores who made what changes, when, and what changes were exactly made. All this information is stored in this thing called a repository. And the thing that makes version control systems so amazing is that changes that are unwanted are so easily revertible. You can undo changes in a flash. So for those of you who've used Google Docs, you may have seen this screen. This is actually very similar to a version control system. You can see here that in this Google Doc, you can see who made what change at what time. And I'm able to revert to this version of the document by just clicking that restore this version button on the top of the screen. So Git works in a very, very similar way, where each bundle of changes is stored in this thing called a commit. And each of those commits are associated with certain users that contributed to that commit. It has a date to the commit. It has information on what files were changed on that commit. So you can see at each step who made what changes at what time, just like with the Google Doc example. So imagine a world without version control. Let's say me and Kate are working on a project, and Kate makes this wonderful version 1.2 update. Well, how would she send that version over to me? She would either have to email it to me. Maybe if we're both on Mac, she'd have to airdrop it to me, but both of those don't sound like great ways to send code over. And to top it off, if Kate makes changes to this version 1.2 after I've received it, well, there's no way for me to see those changes until she sends the code over to me once again. So it's a very inefficient way of like sending code back and forth without version control, and that's what makes version control so valuable. A quick word on distributed versus centralized version control systems. So these are two different version control systems that are commonly used in the world. Git is a distributed version control system, and the difference is that in distributed version control systems, each team member has a copy of the project on their local machine. The server has a copy as well, and the server's copy is basically the master copy. That's the one that's running your app. On the contrary, in a centralized version control system, only the server has a copy of the project. Team members connect to the server and make edits and contribute that way. But the key difference is that in a distributed version control system, each member has a copy on their local machine. So if that's a little confusing for you, here's a little depiction. Imagine me and Kate are working on a project once again. And if we're on a distributed version control system, you can see that both of us have copies of the project, and the server has its own copy as well. But in the centralized version control system, you can see that only the server has a copy of the project and we have to connect to it. The reason why centralized version control systems aren't as frequently used is because if the server goes down, well, there's no way for us to communicate. Whereas in a distributed system, we still have our commits, basically the history of changes that are made, all stored on both of our computers, and we're still able to collaborate on code that way. So yeah, hopefully that makes sense. Hopefully you can see why version control systems are so popular. I will note the one downside of distributed version control systems is that it takes up much more space because you have to have the entire copy of your project on your machine. But that's about the only downside. So yeah. Anyway, yeah, let's get started. I'm actually gonna do a demo along with the lecture today. So if you'd like to follow along, you can do that. Just make sure you have Git installed. And to do that, I'll just quickly show you how to do that. Just look up Git download, and you can click on the first link right here. And download it for your operating system. You might have to restart your terminal after you do so, but yeah, just download Git. And if you would like to follow along, let's get started. So to start a project, we first have to start a repository on the server on GitHub, because that's where all our code lives. So let's do that. First, let's go to github.com. And we can click on this plus and click on new repository. We can give it a name. So let's just call it optional Git demo. A lot of the time, you'll name this after the name of your app. So, if you recall the GitHub page of app dev, it was like pair backend, it was like pair iOS, eatery backend, and so on. For now, let's make it private because this isn't going to be an actual project. And let's create the repository. So going back to the slide, there's two ways to start a project. You can either git init or git clone. Init is short for initialize. And the difference between these two is that git init starts a project on your local machine. And after you start a project on your local machine, you have to link it with the server's copy. Whereas git clone takes the server's copy, makes a local copy, and makes that connection for you. So in short, TLDR, just use git clone. It's more convenient. And I'll show you how to do that. So if you look at the screen after you've created a new repository, there's actually instructions on how to initialize a project using git init. But the way we're going to do it in this demo is just by cloning it. So to clone it, you just have to click on this little copy button. So let's do that, or you can just copy this in Control or Command C. Let's go to our terminal. And let's go to an appropriate place where we'd like to store our project. And from now, you can type git clone and paste the link you just copied. So it told us that we cloned the project successfully, but it gave us a warning that we have cloned into an empty repository. Don't be alarmed by this. This is simply because our repository is empty. So if you look at my Finder, you can see that in optional demo, which is where I made the repository, I got my local version of the project. And that's the exact same name as a repository's name on the server. So this is a local copy of my Git repository. Now, another important thing that you should practice with Git is having collaborators on your project, because that's the whole point of Git in the first place. So in this demonstration, I'm actually going to be adding someone as my collaborator to this project. By just typing in their GitHub username, you can add collaborators to a project. Let's click that. And now they should get an email that you've invited them to a repository. If you're with someone, you can practice this. It's going to be very important for you to practice how to solve conflicts, which we'll discuss later, where two people edit the same body of code at the same time. But for now, if you'd like to just practice on your own, you don't have to do this. Cool. So now that we've initialized the project and have our local copy of a Git repository, let's talk about how Git works, the core of Git, the workflow of Git. So here's how Git is split up when we're working on a project. There's 3 parts to the Git workflow. There's a project directory, which is just a local folder on your computer. There's a staging area, and there's a Git repository. The staging area is what makes Git so exceptional compared to other version control systems, because not a lot of other version control systems have a staging area. So we'll discuss how these work in the next slide. So again, the project directory is just a folder on your computer. And the staging area is this magical area where you get to check if the modifications you made in the files in your project directory are indeed the changes you'd like to make. And the Git repository is, again, where all the commit history, the files, everything is being stored. So let's say we make some file changes in our project directory. After we make these changes to the project directory, we then have to add them to this thing called the staging area. The staging area is, again, where you check if these changes are, in fact, the changes you'd like to make. If you're sure that these are the changes you'd like to make, then you turn it into what's called a commit. A commit is basically just a bundle of changes clumped into one entity. Note that a commit shouldn't be too small and it shouldn't be too large. So you shouldn't have a commit that's just a 1-line deletion, but you shouldn't have a commit that's implementing a whole feature. And then once you're sure that this is the commit you'd like to push, we can push it to our Git repository. This counts as a commit, and this counts as a bundle of changes, and it gets recorded into our history log. Again, a commit contains a lot of information. It contains who made the changes. It contains when the changes were made. It contains what files are modified and how. And it also has this thing called a commit message. A commit message basically is specified by whoever is making the commit, and it should always be descriptive. It should always entail what the commit did. So if you look at the commits made to, say, our backend for pair, you can see that each of these commits aren't too big or too small. For example, the commit Noah made on November 15th just adds a few filters to our matchmaking system. The one made on 27th is implementing notifications, and all of these are little commits at a time. So let's practice making a commit and making changes to our project directory. Let's make 2 files, shingo.txt and gordon.txt. Also, 2 quick things. One, make sure you're in the project directory, otherwise your changes won't be counted. And the second thing is, I've heard a few people tell me that touch isn't a valid command on Windows. So I found a Stack Overflow post where you can instead do this command with the file name here to create a new file. Sorry, Windows users, I did not account for you guys. Okay, cool. So we created 2 files, gordon.txt and shingo.txt. So let's make some modifications to them. To shingo.txt, let's add Shingo's favorite fruit is cantaloupes. And to gordon.txt, let's add Gordon's favorite fruit is strawberries. Now that we've done that, we have to add those 2 files to the staging area. To add files to the staging area, you simply have to do git add followed by the files you'd like to add. So you can do shingo.txt and we can git add gordon.txt. Note that you can do multiple files at a time by just having a space in between the file names, which is super cool. And another thing you can do is just add everything that's changed in your current directory. Again, dot indicates current directory. And if you do this, you'll add every file that was in your current directory that was changed to the staging area. The way you check which files were added to the staging area is just by doing git status. Here you can see that there's 2 files that were edited and they're ready to be committed. So let's review the files, right? They look good. So let's turn this into a commit. The way we do that is by using the command git commit, -m for message, can't forget that, and then the message description in quotes. Now, obviously, we can title this something like add gordon.txt and shingo.txt. However, this doesn't tell us much. Again, to re-emphasize, Git commits have to have a meaningful message to go along with them so that when you're going through the commit history, you can tell what each of the commits do. So here, let's just do add friends favorite fruits. Cool. Now, the commit was made on my local Git repository. To have these changes reflected in the server's repository, we have to push the changes to the server. So that can be done by typing git push. And now if you check our repository and I refresh, you can see that our two files have indeed been added. Cool, awesome. So we just git pushed to push our changes to the server's repository. What if we want to have our local repository updated with the server's changes? Then we just run the opposite command, git pull. So Gordon just added another line in his text file. And you can see the change right here. This is how you can see commits and what they changed. If I want to see this change being reflected in on my local repository, I can git pull. And you can see that now those changes are reflected on my computer as well. Conflicts. Conflicts are going to arise all the time when you're collaborating on code. So this is going to be very important. So cool. So when two people make changes to the Git repository at the same time, a lot of the time GitHub will be smart and figure out how to merge those two changes together. So let's say I edit file A and Gordon edits file B. Well, there's no conflicts there because GitHub will just accept both of those changes at the same time. However, what if I edit file A and Gordon edits file A, or Gordon deletes file A and I edit file A? In those cases, Git doesn't know which change is correct, and a thing called a merge conflict will arise. These merge conflicts have to be manually solved, and it has to be solved by the last person who's trying to make the change. So let's simulate a merge conflict. I'm going to edit shingo.txt. Let's add Shingo's favorite fruits is cantaloupes and apples. And Gordon is actually going to change shingo.txt on his end. Now let's add the change I made to the staging area. And let's make it into a commit, update, or add another one of Shingo's favorite fruits. And let's try to push this change. So you can see that my push actually got rejected. Why is that? Well, that's because Gordon changed shingo.txt, I changed shingo.txt, and GitHub doesn't know what change to accept. The way you can solve this is pretty simple. The message is going to be initially intimidating, but all you have to do is git pull. And you can see here that it's telling me there was a conflict. There was a merge conflict in shingo.txt. So we have to manually change the file and fix this merge conflict. So there's another reason why we recommend VS Code. If you see to the left, you can see the two files that are in my repository, gordon.txt and shingo.txt. Now, the merge conflict happened in shingo.txt. You can see that it's clearly indicated by the red exclamation mark and the red text in the file name. So if I click on this, you can see that there's two versions of shingo.txt that's shown to me. Above is what I put, and below is what the server had, which is basically just what Gordon had. This is great because you can visually see the differences very easily. And to fix this manually, all you have to do is just delete whatever you don't want. So you can see that I actually have a grammar mistake, so let's fix that part. But then maybe my favorite fruit is apple, or apples and not grapes. So we can just delete this. We can delete this head stuff. By the way, these arrows and the dashes are just to indicate where the changes start and where the changes end for both versions. But you don't have to worry about it too much. VS Code will make it very visually pleasing for you. So now that we fixed the merge conflict, we can re-add shingo.txt to the staging area. We can make it into a commit and say fix merge conflict. on Shingo's fruits, and we can push. Amazing. So if we go to the servers repository and refresh the page, voila, you can see that my file is now here and it works completely fine. Next, let's talk about branches. So branches are very, very useful if you want to work on features that you don't want impacting the main body of work. You can think of it as a separate line of development. So if you wanted to work on a feature, say you wanted to add a chat system to an app you already have, you would have a separate branch for working on that chat feature. You can think of an entire project like a tree. So here's a little drawing of what that looks like. Each of these circles represent a commit. So your main branch is going to have a few commits, but let's say you want to stray away from the main and not impact it, and you want to work on your own feature. Then you would branch away from the main branch and start working on commits that you don't want impacting the main branch. So let's create a branch on our terminal. How do we do that? Well, first of all, we can check which branches currently exist by the command git branch. Right now, I didn't make any new branches, so the only branch that exists is the master branch. This is where our main body of code lives. We can create a new branch using the command git checkout and flag, the -b flag for indicating a new branch. And a lot of projects will have very standardized ways of naming branches. In app dev, we use first name followed by a dash, followed by the feature we're working on. So let's add friends, favorite, media. Cool. Now if we do git branch, we can see that we have two branches. To switch between the branches, we can do git checkout and the branch name. But when you're doing git checkout and you want to check out to a new branch, you have to have the -b branch, otherwise it won't work. Cool. So now that we're on a new branch, let's add a few things to our text files. So let's open shingo.txt and let's open gordon.txt. And let's add Shingo's favorite TV show is The Disastrous Life of Saiki K. And let's add Gordon's favorite TV show is Brooklyn Nine-Nine. Let's add the two files to the staging area. Right, we can check that by git status. Let's commit these, add friends favorite TV shows, and let's make another commit. Let's add Shingo's favorite song is Peace Sign by Kenshi Yonezu. And let's add Gordon's favorite song is Kai Kai by Eve. Let's add those to the staging area. Let's commit, add friends, favorite songs. Now let's push these changes. Now you can see that there's a little error here. This is because the destination of git push wasn't specified. It still thinks that I'm trying to push the master, but I'm not on the branch master. And to fix this, you simply just have to copy this line that it recommends you, and you'll be able to push successfully. So now that we've pushed, let's go back to our GitHub. Let's go back to the servers repository and check how that's doing. So you can see here that the changes I just made aren't reflected on the master branch. That's because I wasn't on the master branch. If you look at shingo.txt, my favorite TV show and my first song is not there. We can switch branches by clicking on this and viewing this branch. And now you can see that the changes actually were made in this branch. Now you can also see this yellow text message that just showed up that it had recent pushes and that I should make a pull request. So let's talk about what that is. Pull requests are very important. Essentially what it does is it allows you to merge your branch with the master branch. It allows you to basically add your feature back to the main branch and not have it be like a little branched off development thing. When you make a pull request, you oftentimes have to have approval from other team members to look over your code just for quality check. Yeah, and to reiterate, their role is to look over your code, make any comments, request for changes if necessary, and approve of it if it looks good. So let's make a pull request. Yeah, again, so like I mentioned, in pull requests, you should have a meaningful title, so it's clear what the pull request is doing. And oftentimes when you're working on projects, you would have a standardized format to fill out here, like a template. So it could be like changes made, add friends, favorite TV shows, and add friends, favorite songs. Here we can request for people to review our pull request. So let's add Gordon here. And let's create the pull request. So you can see that Gordon just got requested to review my pull request. So you can see here that Gordon just reviewed my pull request and requested changes. He indicated that his favorite song isn't actually Kaikai Kitan by Eve, but Deja Vu by Olivia Rodrigo. So to address these changes, let's go fix the file that I messed up. Cool. Now let's make another commit to add those changes. Fix Gordon's favorite song. Push. Cool. Now that we've done that, we can see that that commit was just logged here. And if we look at the branch itself, the code itself on the branch, Gordon's song was indeed fixed. So now that I've addressed those changes, actually, let's make this thing called a GitHub issue. This isn't very important. This is just to keep track of what needs to be fixed in your project. But let's say I want to fix Gordon's song, and that's an issue on its own. And I can leave a description if I want to, but let's just make that a new issue. So let's say this was an issue that I created earlier. It's an issue that's been persisting, and we finally addressed it. We fixed it. So in our pull request, we can actually reference the issue by typing the number of the issue. So that this one is #2. Pull requests work the same way, and it's #1. So addressed issue in #1. You can see, or #2. You can see that when I type hashtag, GitHub automatically knows that I'm trying to address an issue, and it'll pull up the issues and the pull requests that exist. So let's do that, and let's comment. And now GitHub automatically hyperlinked the issue in the comment. So if I hover over this #2, you can see the exact issue that I just addressed. It's this issue right here. Now that this issue was fixed, we can just close the issue. Now, if we go to issues, there aren't any open issues. There aren't anything to fix. This is a great way to keep track of your any issues that persist in your project and reference them in your pull request to say that you fixed them. So now that we addressed Gordon's concerns, we can request another review from him by clicking on re-request review. And now you can also see that the comment that he made is now updated because that is no longer the file that exists because I made the edits to it. This time he approves. He says that it looks good to me. Thank you, Gordon. And now I can merge this branch with the main branch. So let's edit the message. And let's confirm this merge. And now the branch that I was currently on just got merged to the main branch. So all the main branch just got the changes that I made into this branch. Now that that's done, since branches are usually only for working on one feature at a time, we can just go ahead and delete it. And if we go to the master branch or the main branch, we can see that Gordon's favorite song and his TV show and my favorite song and my TV show are all here. Cool, so let's see what it looks like from our end to review a pull request, because you'll need to do that as well. We can click on pull request. You can see that Gordon just made a pull request. He wants me to review his code. So we can click on files changed and see the files that were changed. So he added that Gordon's favorite sport is basketball and that my favorite sport is baseball. We can leave inline comments by clicking on this plus. So let's say I want to leave a comment here. Say, really? Basketball, your favorite sport? And add a comment. And you can see that the comment shows up in this specific line. And to request a review or to approve of a pull request, you can click on review changes. You can actually click on viewed to keep track of which files you've actually looked at, and click on either approve with a message like looks good to me, or request changes. Fix your favorite sport. I don't think. Well, let's just say, oops. Let's just say it looks good. So let's submit this review. And now on his end, now he's able to merge it with the main branch. Amazing. So now that that's done, hopefully you guys can see how important it is to have different branches when you're working on the same project with multiple people, and how important it is to pull requests for quality check with other teammates. The last thing I want to talk about is how to look at your history, because again, that was why version control is so powerful, right? You're able to look at the histories, who made what changes and so on. So on the GitHub UI, on GitHub, the website itself, you can just click on this 12 commits button, and you can see all the commits that were made to this project. If you want to see further details on the commit, you can just click on either the commit message or the commit hash right here, and you can see what the edits exactly were. So for example, I added my friend's favorite songs. We can see what songs were added and which lines were edited. To do this on the terminal, on the command line, you can type git log. And on git log, you can see who made what change at what time and what is the commit message. But you can see here that with only about 12 commits, it's already pretty long, this git log screen. So a neat little trick you can do is git log. And with this thing called the flag, you can specify to type out all the logs in one line each. So this gives us the commit hash, which branch it was made on, and what the commit message was. So this is a very compact way of looking through all your logs. Another thing to mention is to revert to an earlier commit. You can use the command git reset or git revert. There's not very big differences between the two, but you can look them up if you'd like to. But I'm just going to go ahead and use git reset. So let's say I want to go back to this change right here. Then I can do git reset and then the hash. You can see that I've actually reverted all the way back to this version, which if we go back to the one line git log is fixing the merge conflicts on my favorite fruits. But you can see that the changes aren't actually reflected. So my files themselves didn't change. The way you make it so your files change is to git reset and then specify this flag called hard. And now the files have been reverted back to that version. The reason why you would want to get reset to a version without hard resetting the files is because if you made any progress up to that point and you'd like your commits in between to go away, but you still want to keep the files, then you would just use the normal git reset command. So hopefully that makes sense. So as a little summary of what we've covered today, there's a few commands that are going to be very, very useful to you guys. So the first one is git clone. Git clone is to initialize a Git project on your computer. Next one is git add. Git add is adding any modified files to the staging area. Git commit is to bundle up all the changes you made in the staging area into what's called a commit. Git push is to push any commits on your local repository to the server's repository. Git pull is to pull all the commits from the server's repository to your computer. And working in parallel is, again, what makes Git and GitHub so useful. So to do this, you would each have your own branch for a unique feature that you're working on. You would pull request when you want to merge your branch with the master branch or the main branch for other team members to quality check your code. And merge conflicts can again happen, but you already know how to fix that through today's demo. Awesome. So for those of you who are watching this, a little announcement that PA1 is due this Saturday with no extensions given. Please come to my office hours or me and Kate's office hours tomorrow if you'd like help on that. There's an ebb post about that. But yeah, otherwise, have a good rest of your day, and I'll see you at lecture on Monday.